Thank you all for joining us after an inspiring opening keynote and fireside chat with Anup from Atlassian and Ritesh, and a fantastic demo of our new AI agents by Thimil. We are grateful to our speakers for setting the stage for an exciting day of innovation. Now, we move from vision to action. Our next session tackles a critical challenge in test automation, overcoming blind spots that slow down progress and impact quality. With the power of AI driven insights, we can now detect and resolve issues that traditional tools often miss. It's my pleasure to introduce Sarthak Gupta, Senior Quality Engineer at Walmart, who brings deep expertise in automation and AI. Sarthak will share Sarthak, um, Sarthak will share practical strategies for breaking automation blind spots and making your testing smarter and more resilient. Please join me welcoming Sarthak to the stage. Over to you, Sarthak.
Hi Manish, thank you for introducing me. I am Sarthak. I am a senior QA SDET in Walmart. I'll start with a brief introduction about what I am actually going to present, and then I'll start my presentation. So my topic for today is breaking automation blind spot with AI insights. Uh, Before starting our presentation, I'll give a brief about what is my topic, what are the contents which I'm going to cover, and then gradually I'll start my presentation and the live demo. Okay. So major pain points for QA automation is that either there is flaky test cases, there is test data which is flaky, or locators which are flaky. How to resolve those issues, how to write automation test cases using AI, what are the issues and how to categorize them, and what to do when there are a lot of flaky test cases. In the end, I'll also give a demo on how to use MCP Playwright server to write an automation just by giving a prompt without writing any of the locators or scripts or weights and any long test cases. In the end, it is also going to give us a generated report. It is also going to give us a framework if you want, and it is going to execute our script just by giving the prompts. Now, moving on with my presentation. Why do we have test automation? It accelerates delivery, it risks the risk mitigation happens, and the resource efficiency is there. Then we come to what are the core automation challenges. Core automation challenges includes script time creation, test flakiness, as we have already discussed, onboarding complexities, and critical failure blindness. Now, onboarding or complexity means that whenever a new resource is onboarded, he or she takes some time to understand what is framework, how to write there, and what are the places where they can use the reusable components. Then comes what are the additional pain points which we have. It has segregation issues, then it has data challenges, it has maintenance burden for the complete test automation, and then it has environment instability also. Now comes the objective. Objectives are what is test data, test execution analysis, what is dynamic failure analysis, smart test data management, and automation script generation. So test execution can also be analyzed. Why are the test scripts failing? Are these scripts which are failing continuously? Is it because of some change recently, or they are flaky test cases? Moving forward, how AI-driven automation can be benefited. It has pattern analysis, it has intelligent classification between stable, flaky, and high priority test cases. Then it has dynamic optimization. Dynamic optimization means that either if there is a flaky test case, it is also going to retry. If there is some locator which fails, it is going to fix the locator and then retry. Moving forward with what is AI-powered test architecture. AI-powered test architecture includes AI engine, which is going to analyze the historical test data, predict the failure patterns. Then there is test selector, which is going to select the test cases which are mostly passing. They're going to use them, run them first, and those mostly passing test cases would be run less number of times with respect to the flaky test cases or the test cases which are failing. Then comes execution optimizer. That is the optimizer which is going to execute our test cases parallelly or sequentially for maximum efficiency. Then comes the result analyzer, which is going to actually analyze the reports, tell you where is this flakiness, what is the issue. BrowserStack has a very good feature where it can understand and analyze what are the reports, how many percent, what is the percentage of the reports which is stable. That for example, here in the screenshot we can see there are around 9,116 test cases which are executed, out of which 35% failed. Stability was somewhere around 81.4%. Then there is also details about what are the platforms which are covered, what are the build performance of it. If we'll move further, we can see the stability with test case which are always failing. Then we have flakiness, we have failure categorization, we have new failures which have recently been introduced by the new commits. And then there are new test cases which are executed, unique test cases which are executed across all the projects. Now, there are a lot of widgets which BrowserStack dashboard uses. Some of them are aggregated summary, build summary, stability, flakiness, failure categories. All of these are going to help us to categorize these are flaky test cases. Let us work on them more. Or else these are the test cases which were passing earlier and failing, might be potential bug is there in these test cases. Then comes what are the real world examples before AI implementation. Let us suppose there were 1,000+ regression test suits. After AI implementation, 60 prioritized test cases are sufficient, 600. It takes 2 hours to complete runtime. Then it is reducing our 50% efforts and can be completed into 1 hour. Then before implementation, there were many stable tests which used to run redundantly, therefore utilizing lot of our resources, which is actually not required. With implementation of AI, it is going to higher defect detection rate, so that defects could be detected and could be resolved. Then we have critical issues sometimes which were missed before AI implementation. These resources here after implementation of AI, these resources could be easily freed and via exploratory testing. There can be a good amount of usage for AI test data generation and management. Now, test data acts as a very important part for AI automation, and for any manual validations. Now, how can we work on test data generation part? We can use mocking preconditions. We can use golden data set creation, maintenance of the golden data set, and enhancement of that golden data set as the quantities or the quality of that golden data set deprecates. There can be, as I've already discussed, dynamic failure analysis includes predictive failure analysis, where it is going to, on runtime, it is going to understand the historical test data. It is going to read the real-time system logs and is going to create or generate performance matrices. We can also identify the RCA for test failures and then detect correlation between test failure and commits and accelerate debugging. In the end, AI-powered test generation can have self-healing locators, can have test data generated by AI, we have script generation, and there is multi-agent optimization. So now we are going to discuss about the difference between generative AI, agentic AI, and MCP, that is Model Context Protocol. Generative AI works on pattern recognition, content creation, and data synthesis, whereas agentic AI has goal-oriented actions, it has a strategic planning, and it has autonomous execution. Whereas Model Context Protocol has historical tracking, long-term learning, and then context awareness, as it stores the context and then perform action accordingly. Now moving on with what is MCP. So MCP, Model Context Protocol, is a protocol which is introduced to us by Anthropic. According to modelcontextprotocol.io, MCP is an open protocol that standardizes how an application provide context to LLM. Think of an MCP like a USB-C port, which is a common definition which is given to MCPs, that MCP acts as a USB-C port for all the AI applications. USB-C port has gradually become a common port for us to connect all our devices. Similarly, if you can understand with an image also, our MCP here is a C port which connects to our MCP client, whereas all the different kinds of tools or different MCP servers are connecting to this C port. Therefore, MCP provides a standardized way to connect AI models to different test data sources and tools. Now, let us talk with an example. LLMs in their fundamental forms, it excels in generating text based on patterns, learns from vast test data. However, they lack inherent abilities to interact with real world. This is what happens when generative AI was working with. It is similar to our chatbot, which used to give us a generated data, might be in the form of our code, might be in form of our images or some other sorts of media. Now, when agentic AI came into picture, it started interacting with different sort of tools. So now LLM, which used to be a generative mode, is now interacting with these different kind of tools, getting an action performed, and in the end, returning a result to us. For example, help me analyze there is a call center executive who is giving a feedback or a prompt to LLM. Help me analyze recent customer feedback from database, Zendesk tickets, and social media. Compare it with latest software release notes for a local file, suggest potential improvements. Now, what is it going to actually do? When this prompt goes to an LLM is large language model. Now it is going to connect with different sort of tools. It is going to connect with database. It is going to connect with Facebook API. It is going to connect with Zendesk API and the file system to get all the data related to this feedback, customer feedback form. And then connecting all these tools together, it is going to generate a response to us. Now, when we talk about MCP, earlier, in order to connect with all these different tools, you can see here, LLM is going to connect one by one to all different tools. Integration between all these tools has to be written somewhere. Now, with the MCP, same problem statement. How are they going to move forward is, LLM is going to connect with MCP client. MCP client is going to connect with MCP server, and each MCP server is integrated with a specific tool. For example, SQLite has a different MCP server, and Facebook APIs will be having a different MCP server. We have Zendesk, which has a different MCP server, and then we have file system, which has a different MCP server. Now, MCP client is going to connect with these tools, interact with them, get response, and give it to LLM to manipulate it and then give a final response. Now, the structure of MCP systems involve a client-side system and a server-side system. Client-side system involves LLMs and MCP client, whereas server-side system involves MCP server and the service, that is the tools involved. In this image, it is a Google Calendar. Now, these are the references and contents which you can refer to. There are very good content, and you can get a onboarding steps also how to start using these MCP servers. In this demo, I'm also going to present a live demo for connecting with MCP server for Playwright, how to execute them. I'm going to use MCP client as cursor and then going to interact with MCP server, that is of Playwright. So now I'm going to let us move towards our demo. We are going to use, as we have discussed, cursor as MCP client. Now this is how cursor looks like. It is a fork over Visual Studio Code. It has a agentic AI integrated with it. As you can see in new chat, we can see agentic AI integrated. Currently, I'm using Claude 3.7 Sonnet. Now, when we go to cursor in settings, there is cursor settings. In MCP, you can add new global MCP server. It is going to open this mcp.json. While going to, you can search for MCP playwright server. It is going to give a GitHub link for you where you can, it has full settings on how to configure this playwright server to your cursor. Now copied this playwright configurations, example configurations here, and then saved it. Once it is saved, when you click on MCP, the playwrights, you have to restart cursor. It will get automatically enabled, and then we can start our prompts. Now here what I'm going to do is I'm going to open Go IVivo. I'll open Go IVivo and then I'll click on here, write Bangalore, select enter, will write Delhi, select enter. For today's departure, I'm going to search for flight. Now while I'm searching for flight, all these flights are visible with view fares. Now I have to select view fare of flight which has amount of 8249 or 8559 with Air India flight. It is going to open view fares. Now, when we open view fares, we can see multiple book now buttons. It is going to exactly click on book now button of price 8559 without giving any locator, just by writing a prompt so that our AI systems could understand which book now button has to be clicked. Now, when I click on this book now button, a new page opens, a new tab opens, and it is going to fetch details for us. Once the page is loaded, it is going to validate that the endpoint which was loaded is this or not. And then it is going to close our execution, close Chrome, and generate a report also for us. This is our practical demo. What I'm going to start with is to write the prompt to make the MCP server or the AI understand that what has to be done. I'll write, use the MCP playwright MCP server to navigate to the website, that is https www.goibevo.com. Now we ensure that the MCP server is actively handling the browser automation and validate the integration. Now I'm also specifically mentioning perform actions which are listed below only. Do not perform any action, any other action. What are the actions? So this is select light and book now scenario. Step 1. Once the MCP once the GoIbibo but website is launched, now we have to reload the page. Why am I reloading the page? Because when I open this GoIbibo, initially it is going to give me a login button, a login screen. If you want to log in, you can directly write your phone number and then continue. Here in this scenario, I'm trying to avoid this and directly start searching for a location. Reload the page. In the, if you can see here, what am I trying to do is in the from, I'm going to enter Bangalore, and in two, I'm going to enter New Delhi. So in the from text box, enter text Bangalore, Bela. I have already written a prompt, so I'll put this line by line there. Just give me 1 second. Not copy pasting. So now my third step would be once we enter BLR, Bangalore, and then I have to press enter. Same thing I'm going to do for 2. In 2, what I'm going to do, I'm going to enter New Delhi. And once it is done, we'll press enter button. Now, once enter is pressed, what I have to do is I have to click on search flights. So my next prompt would be to click on search flight button. Now, once we click on the search flight button, I am navigated to flight search page. And a pop-up opens, new log prices and pay later. You can click on OK, got it. So my next action would be click on OK, got it. OKAY, got it one. Now I want to select a flight which is Air India flight, and the cost of that Air India flight is 8559. So what would be my prompt? It would be click on the fares button for 8559, which is an Air India flight. Now, once it clicks on this view fares, there is a pop-up or a model opens which has different fare options. My next task is to click on this button, book now button for the price that is 8,559. Now, when I click on this 8,559, it is going to click on buy now, a new tab opens, and then it is going to validate that the URL should be flight review details itinerary. I'm going to copy that prompt and then put it here. New browser tab opens, switch to the new browser tab. The new browser tab should contain endpoint this and then close the browser. In the end, I have to also generate a HTML report which has each step by step for pass and fail. It is also going to have a donut chart with the report, and the file of the report, the file name of the report will have the timestamp. Let me copy that prompt and put it here. And let us run this. Now, as you can see, it has started performing some action. Chrome browser has opened here. We can see in the logs also that it has opened now. I'll reload the page. It has reloaded the page. Then it should be identifying where is this from and what is the text box for it. It is going to enter Bangalore there and then press enter. Now I'll enter. Similarly, for New Delhi, it is going to identify where is to New Delhi, and it is going to remove this New Delhi and put New Delhi and then press enter. In the end, it is going to click on search flight. Done. Now we are navigated to another page, that is search flight page, where it is going to click on view fares only for Air India flights. That has a cost of 8,559. It has clicked on book now button, navigated to new tab, and then switch to this, validated that URL, and then close the Chrome. Now it is going to generate an HTML report for us, flight booking report.html with a donut chart. It is going to have steps for pass and fail. While it is generating report, I have already generated a lot of other reports which has pass, fail, and other scenarios. Let me show you the ones which are already generated. This is one of the report where I was validating BrowserStack. I've explicitly wanted to validate test management should have a product number as 19. It failed, saying it found 15. Donut chart shows us that one test case failed. Similarly, I have tried to generate all the charts which were easily possible by Python, I would say. And there are pie charts, there are donuts, there are bar charts, horizontal bar charts, watch charts. The major scenario which I tried to execute was to log in into a sauce demo and then standard user login, secret sauce, then click on login button. Login button was not found, therefore further steps were not executed. Now you can see that our HTML report is generated. It is present here, flight booking report.html. So now as you can see that we have a flight Indigo flight booking test report. These are the test steps which were executed. It has test scenario results, navigated to Goa Bibo, reload the page, Bangalore to Delhi, and then select the flight, click on got it button, price, check the endpoint and close the browser. Then it has also given a donut chart. It has given the summary that the test steps were 13, pass were 13, and pass rate was 100%. This is the total our working demo. In the end, what I would like to say is that these are the reference content which you can read, and this is very good content. In the end, I would like to thank you all. We are not replacing QA engineers. We are empowering them to act faster, smarter with insights using AI. Thank you.